Okay. So today we will discuss, continuation of Docker part. Okay. Like yesterday we discussed, today we will go through the Docker volume, Docker network, like that. Docker volume, Docker network. Then we will deploy some sample other application. As of now, we deploy HTML application, right? So today we will deploy some other application. We can take some Node.js application or Java application like that. Okay. Node.js app. Then we will use one repository based application also. Okay. That's what we discussed. Taking one repo for a application and using that repository, we will build and run containerized application. Okay. So first we can go through the Docker volume part. Okay. So the volume is yesterday we discussed, right? For persistent data, we will create volume, right? So first we create a volume in our host machine, volume created. After that we mount the volume with the container directory. So this is the format. So for that, first we need to create a volume using Docker command. So Docker create volume name. So we can jump into the lab, right?
Yes, please.
Hmm. Okay, first time launching one is animation to do the lab. Okay. Also, I am selecting T2 medium. T2 micro is also fine, but I'm going with the T2 medium. Okay. selecting PPC and public view network, subnet. That's fine. Now I'm going to launch.
Now, if we can make use of, like, we can create the security group and we can attach it whenever we are launching EC2, right? Instead of creating a new security group.
Right.
Okay.
Here you can see by default, whenever we launching a EC2 mission, by default, AWS will create a security group here. The name,
Yeah. That's what.
it's a default name there. Okay. Like we launch Wizard 51, 50, 53, like that, whenever we launching different mission. Or
But
else
we
if we have, yeah,
yeah.
or else if we have a specific security group with the corresponding port open in that security group, we can also attach or existing, we can select existing security group as well, in that stage.
Okay.
Okay, now we are updated the package manager. So we can go with the Docker installation. -y. Okay, Docker PS. Yeah, Docker is up and running. Now our requirement is we need to create a volume, right? So creating a volume, and we need to, after creating volume, we need to attach a sample container with the volume. Then we will try to uh, like add some data or anything. Then we will check. Okay, then we will remove the container or we stop the container or terminate the container. Then we will verify the storage that is still persist or not. Got it. So first I'm going to create a volume. Docker create volume. Then volume name. Okay, like we can define any name. Okay, my volume. Global. So this is the path, okay, where in locally where the volumes and everything we can find under the uh, Docker directory. So now I am in the Docker directory, okay, var lib Docker. So here you can see volumes less. So as of now, you can see there is no volumes are there, okay, because we don't create any volume or else we did not create any container actually. So now we are going to create a volume. So Docker volume create my volume. So now Docker volume created. Okay, the name is my volume. Now I am going to type ls. Okay, so you can see volume created. So in local machine we create the volume. The next step is we need to attach this volume or mount this volume to a container. For that we can just run some sample container. Okay, Docker run detach mode name test container. Then now we are going to create a container. Okay, this is a directly we just run a container. Okay, using a sample image called busy box. So it will create a container, and also we are going to attach that created volume. Okay, so in this case we need to define the volume flag as well dash v. Then we need to define the volume name. Okay, after dash flag dash volume flag we need to define the volume that we created, my volume. Okay, now we are going to mount with some directories within the content, okay, like app data. This is fine. Now we need to define the image for running this content, okay. So for a simple process or test process, we can run a busy box content, okay. So it will create a small image, means creating a container. And also we can see inside the container, we can see there is an app data directory there, and that directory inside the data. Okay, coming to data, if we store anything inside the data directory, that and after we deleting this busy box container, the data will be persistent in the my volume. I mean, we can see in the local machine also. Just open the my volume directory, we can see the data. Okay, I'm going to yes, yes. Okay, I will use some other images. Okay, instead of VC box, we can use some other image like. So given a name and Nginx. Okay, Nginx is running fine. So that's good. Okay. So we created the volume and we attached the volume with the Nginx. Okay, the about 200 is not running, actually going to exit state. So that's why I'm changing the image name. Now we are going to execute, or we are going to write some data, okay, to the container path data, app data. For that, we can run docker ex, then the container name, est. Then we can use a shelf command. Okay, so what will happen? It will it will open a shelf and write out the command that we are going to type in the echo.
You can ask for the no, 10 no, we look at flash. Oh.
So echo, then type I this volume is persistent. Okay, now we are going to close, and now we are going to write. Okay, write this data to be using this symbol. Then we need to define the directory inside container. Okay, app data. Then the name of the file, like test.txt. Now it's fine. So also I'm going to check. Okay, just to log into in bash. Interactive. Okay, IT. Now we are inside the container. Okay, ls. So here we can see app directory. See the first one, cd app ls. Now you can see the data directory, cd data ls. See the file we created. Okay, using the exit command. Okay, this command actually created a volume, and inside the test we can see cat es dot txt. See the data is here. Okay, now we are going to exit this container and verify the data is. Now I am in the correct directory. Okay, in the local machine. See, now I am typing ls. See the my volume, that volume that we created. My ls. See, you can see the data, right? See data ls cat est.txt. See, same data will be here in our local machine volume also. Now I am going to delete the container. Okay, docker ps. Okay, here this is the way we inspecting Docker volume. Okay, the volume we have created. So here we can see everything that created date, the driver, local, that means in local machine. Then the mount point as well, we can see. This is a mount point. My volume data. Now I'm going to stop the content. Okay, stop. Now it's stop. See, Docker PS, nothing running. And also I'm going to delete or terminate this container using Docker rm command. Okay. Fine. Now we can't find this container. Okay, it's totally removed. Now you can see when I'm typing, the container is gone. Okay, container. Docker PS not here. Also using a flag, you can see no containers here for the Nginx. This is for the busy box. Okay, the first two times we created. Okay, everything is gone. Yes. So now it's clean. Okay. So now we need to verify the data is still there. Okay. Cat tbst.txt. See, our data is still persistent. So this is the way we use Docker volume. So our data will be safe. Okay, if the container will stop or will go. Got it.
Yes.
Also, we can use the same image to another container. Okay, if we create another container and we can mount the container, another container, the same volume, and also we can see the data inside the container. So this is fine. We can build one more test container. And also I am adding the volume, this volume, to the directory, app data. Hit enter. Now it's fine. Docker PS. I'm logging to the container. Okay. Docker exec dash container name or container ID. Then bin bash. Okay, here I'm going to check cd app plus cd data. Our requirement is the same data we can see here. Okay, let's see. The data is here. So this is the way we creating Docker volume from scratch and mounting with a new container. And after write some data, okay. So this is the data we write, okay, when inside the container. manually. And after we terminate the container and verify the data is persistent in our local volume, then we will create another container and verify that the same data will be in the new container as well. Got it?
Now we are mounting the data to a container, right? We
Yes,
are
yes.
redirecting that to one directory, right? Can we go with any other directory other than app, or do we need to go only with
Yes,
the
we can go. For example,
do we need to remove it after stopping?
yeah.
Okay.
Now our requirement is we need to create another directory, right?
Yeah. Can
Or
we
else
do?
we need to mount with not the app or any other directory. So we can create a test directory. Okay.
And when we are creating the volume, do we need to go into the Docker directory and create the volume, or we can create the volume outside too?
Outside, because the volume actually created in locally actually, okay. Coming inside,
No,
inside
that's
Docker.
what. No, not I'm not talking about the Docker. Like in the local, in the Docker directory, you have created the volume. Initially, you
Right.
have created outside, like local outside Docker, but somehow it's shown some error, and you have gone through local Docker directory and you have created the volume.
No. That's the error is related to the command mismatch. So locally,
Actually,
after installing Docker, we need to run the Docker volume creation command. Docker volume create the name. That's all. That's the format.
okay.
Yeah. So here you can see now we created a test directory here. See the test. Instead of app, now we mounting our volume to the test directory. Okay. CD data ls. See the file test file is here. That's not an issue. We can mount any
Oh,
directory.
we can give any name.
Yeah. Because there is a lot of applications that we are going to do in content, right? So each application directory will change actually. So this is a test case that's how you use the app data. Okay, app directory. Inside
Okay.
app directory, there is a data directly there.
Okay.
So we can now next thing is we can deploy a sample Node.js application. Okay. So as of now, we only created a web application, right? I'm going to exit CD home. Okay, fine. Now I'm going to create a Docker file. A Docker file. So if we are using a node application, okay, so we can define the node official or node base image, okay. So that node base image including the node uh, function and features also with the minimal operating system feature as well, like user workspace or binaries, libraries for running a local small minimal OS. For that, we can use instruction command from, and we need to define the node image. You can go with the node, different versions are there or latest, or I'm going with the 16, okay, node version 16. Now the next thing is it will create a working directory, okay. So we can use a work directory instruction. Work dir. This will ensure that whenever the container created, okay, then it will create a directory as well. The directory we can define here. Like similar way we can define test or any directory here, okay. Then we can use the copy instruction. So for Node.js application, the application dependencies, okay, the developers defined in the package.json file, okay, package.json. So in this case, whenever the container is going to building or starting, the Docker file looking for the package.json file, and inside the package.json file, they have defined the dependencies, okay, some it will download actually. It will download from the internet. Then coming to Node.js application, okay, the npm node package manager, that's npm, okay. The npm command we are running to, execute or installing the dependencies and execute the application. So we need to define that command in run instruction, that is npm install, npm. That's fine. Now we can copy all the application content from our local machine to container machine. Copy space dot, okay. So it will copying all the directories, files, and everything from our local machine to the container path. For Node.js application, the default port number is 3000. So we need to open the port number as well, 3000. Then coming to the CMD instruction, we need to define instruction and arguments, executable and arguments. So whenever the container start, we need to ensure that the node application is start, okay, before starting our, after container started, then we need to ensure that the node service start, okay, the node binaries. So that we can define here. Also the application code, okay, that is belongs to the server.js. So after running the Node.js service, it will, this is the argument actually, okay, this that will taking the server.js file. So the server.js file is the application file for the Node.js application in this case. So this is fine for running a simple Node.js application. Now we are going to save and exit. The next thing is we need to write up the Node.js application code, okay, sample code. Nano server.js.
Can we give any name like um,
No,
test
server
dot,
code.
only server.js? Okay.
That's a default. So I will take a sample code, okay. This is a sample code, sample Node.js application code. This is nothing actually. It's, display the content, okay. This is the content actually. So exit. Now we are good to run the Docker file. So first we need to build the Docker image, right? Docker build. Node app. Okay. That you can see the copy require at least 2 arguments, but only one was provided. Destination would be determined. So I'm 1, 2, 3, 4, 5. I will remove this one, okay? Because in this case we did not define that package.json file. In a full Node.js application, then they will define the package.json file. In this case, we already define our server.js file. Okay, this is a simple application without a dependency. We don't need dependency to run this application. Okay, I think that is looking for the package.json. Okay, so we need to define that part also. We can type some sample, okay, like for adding one copy instruction. Because by default, the NPM is looking for the package.json. So package, but in this case, we don't create a package.json or keeping in our local working directory. Package.json, and we need to define that path as well. Okay, I will go to the root path. This is fine. Yeah, and exit. You can run it again. Again, some error. page. Just I mean creating two file, okay, and try. So that Docker file is making some issues, so I will go with another Docker file. Okay. There are some simple
Did
Docker
you do
files.
the Docker start on that container?
No, no, no. Okay, this is simple one. So I will go to save and exit. And we need to create a file as well, okay, for the application. Now I'm going to build.
There is L missing in the build.
L missing here.
Okay, that's fine. So this is the image, okay? Image for the node actually. So now we can directly run this image using Docker run command. Using container container machine 3000. Because we open the container machine 3000, right? Then we can define name for the container as well. Name, new app, and the image name. The application is up and running. We can copy the IP. Open the port number 3000. That's fine. We can define the IP with the port number 3000 to access the Node.js application. Fine. So this is a way to deploying a node-based application. Okay. So we'll check with the GitHub for that PHP. Anyone have any doubt?
What was wrong with that Docker file?
For the Docker file, I defined the package.json file actually. So coming to package.json, whenever the npm is trying to install, we define a command like npm install. So whenever it's starting, it will looking for the package.json file. So we need to define that content inside the package.json, the JSON format. Okay, I use some sample text actually there. That makes your writing. So I remove that part actually, because in this case, we don't keep any package.json file. So this is the Docker file I'm using, catch file. This simple file. See, node 16 there, create a working directory. This is another directory like user source app and copy server.js. So in this case, you can see the server.js file here. Then expose 3000, then command. Starting the node and the server.js, whenever the container start. Good.
What if we want to give entry point instead of CMD?
Both we can define. As per the requirement, we need to select corresponding.
But both serves the same, right?
Yes, but different use case. For example, coming to CMD, we can add more. Coming to entry point, we can add more like more arguments. Okay, in coming to CMD, we need to define only a single argument that is not overwritten. If coming to entry point, it's the value will overwritten.
Okay.
I will try to test any Docker here. So this is another Node.js application. You can see from 16 creating a directory, then copy package.json. Okay. Then inbound build. This is a React build path, npm run build. So the package.json file we can see in the directory as well. This is a directory. So this is a package.json. So inside the package.json, they will define the dependencies. See, these are the dependencies and the version as well. So for this application, we can run inside Docker. So just to copy or else, yeah, copy and create a directory. Now using git clone, can clone the entire application. I mean, entire repository here. See that repository you can see here. Now I'm logging to, change directly to the cloned folder. Okay. So here we can see the Docker file. So we can directly build the Docker image using Docker file, Docker build.
Build
L is missing in build.
L is missing.
It will take some time because it's a huge application. Okay, now we are going to run Docker run detachable mode. Then we need to define the port number. Okay, in this case, we already running a Node.js application using the port number 3000. So I'm using 3001. Okay, with the container port 3000. Then the name. And the image name. Docker PS. Head starting. Now I'm going to open one more port. Thank you. Got it. So the application is deployed. So this is the way we using, cloning application from the GitHub and directly running using Docker. So it's simple. Just clone the application and build the application and run the application.
Okay, thank you.
So you don't have any doubt, or else we can wind up today's section, right? Two of you.
I'm good.
I'm good. Thanks for the lesson. Have a good morning, Tawfiq sir. Good night, everybody.
Night all.
See you tomorrow.
We'll meet tomorrow. Okay. Bye. Bye-bye.
Bye.